Welcome, folks. Here's problem 16. Notice here that we've got to add some fractions, even though the denominators are polynomials of various types. We still have to be able to carry this out, have a common denominator. So our first step is to get that second and that third denominator matching the first. And part of our work in this section was to do some factoring. So let me grab a pen here real quick. And first we should analyze this denominator. It would help if we would write this in this kind of a format. So we do want to factor that. And some of us have worked with this larger x type of an idea to help us find those factors. I think it's fairly obvious that these first characters here have to be 2x's. So let's go back and find the other two numbers that'll help us out. Again, the last number in the trinomial goes above, and let's write the correct number there, grams. The last number goes above, and the middle number, which I underlined, goes down below. And then, of course, we are looking for two values that multiply to the 2 and add up to 3. I think it's pretty obvious that these are both a 2 and a 1. Since they're positive, we put a plus sign. And now we've taken our denominator in the first piece, and we've actually have it in factored form. So there are no changes required there. This is just a rewrite of what's already there. Now, my second piece, notice I have one of the two factors required. So I need to multiply this by x plus 1, and of course I do the same to the top so I don't change the value of that fraction. And I'll go up there and copy in the part that was already there. And then I manage the second fraction likewise in the same fashion. Notice I already have x plus 1. The part that is required to make it match the original, or not the original, but the first fraction, happens to be x plus 2. So again, I'll multiply whatever is up there by that same value so as not to change what it really means. And I'll bring back my x minus 1 piece. Okay? So now that I have my denominators matching, and this works also in much simpler cases as well, and I'll just throw another sample problem up here for you, right? So if these denominators match, my only real concern here is what's going on with my numerators. So we're going to temporarily ignore what's going on down below, and we're going to try to manage our numerators by actually adding together likes with likes. So let me see if I can erase a little bit here of what I've put in. It's not letting me do so. Here we go. So we'll get rid of this piece. And we'll work with just our numerators and see what we can make happen there. So, step 1, I want to actually combine this and this and this if I can. Find some answers for x. Notice in this second fraction here, I probably should distribute that first. So I'll just copy my first guy, and I want to add to that 2x squared plus 2x. All I've done there is distribute the 2x to both parts inside the parentheses. On the other side, I should carry out my FOIL process. Minus 1x plus 2x minus 2, and combine any like terms I have. Okay, so far so good. Now let's see if we have anything here that we can combine. Check out the left-hand side here. It looks like that can be simplified 2x squared plus 3x minus 1. And then again I have x squared plus x minus 2. Now I do have some similar terms both on the left and the right. And actually my goal is to get this whole thing equal to 0, because since I have x squared terms and x terms, it's helpful if I set it equal to 0, then I can try to factor. So I'll have to be minusing this x squared over to this side. I will have to minus this x, and I will have to add 2. And when I carry this out, here's what I get. X squared, well that's nice, plus 2x plus 1. And now to factor this, again, I can think of using that x that we had used before. 1 goes above, 2 goes below. Fill in the automatic x's here. Luckily, I don't have a number in front anymore. Otherwise, I'd have to go to a different method. So back to our factor x here, numbers that multiply to 1 and add up to 2. Oh boy, is that easy. Plus 1 equals 0. And now my final ultimate goal here is to actually solve and find values of x that will make this equation true. And I think you realize here that the answer would be x equals -1. If we would chuck a -1 in here for my blue x, in both cases it will turn my product into a 0. So I've come up with an answer of -1. Now let's go back to the original and have a look. And I'm looking at my original here. Let me see if I can erase a piece of what's over the top here so it's easier for us to see. And my eraser is not working again. So we'll try to fight through what's there. Actually, I can use my second piece here. So focusing on our denominators, we said our answer should be -1. Now if I plug that back in the numerator, it doesn't matter what goes on, I'm perfectly fine. But in my denominators, in blue is what I originally had. So notice here there's going to be a problem. If I sub in a -1, I will get an answer of 0 times this other set of parentheses that will generate a denominator of 0. Bad news. Also on the other side of the equals sign where I drew this arrow here, my original x plus 1, if I sub in a -1, I will generate a denominator of 0. Same thing happens if you look back at the original. Subbing in -1s will give us problems in the denominators. So for this particular problem, although we found a number solution, upon further and careful inspection we find that there is really no answer, although we did come up with a value for x that will work for our numerator. Another way to say that is, in the original problem, there are 2 numbers that are not in the domain. Those numbers happen to be, if you observe what we factored here for the first one, we're not allowed to plug in a -1 or a -2. So if the answer you find is not in the domain, then we have to say there is no solution. Maestro, cue the outro music.